Hello, welcome back for lesson 7.5. This is going to be the last lesson of the semester, the last lesson of new information. And so we're kind of putting it all together with the quadratic equation, but really the quadratic function and what it looks like. So let's take a look. We've already done some graphing of what these look like in calculus, but we're going to get into a few particulars today. So just a reminder, we've talked about a parabola is what the graph of a quadratic equation looks like. That's what it's called, a parabola. The graph of a quadratic function. And these would be two separate ones. And I drew them this way because these are the two different ways they can look. This one is face down and this one is face up. So let's just write that. I'm just filling you in some things because when you get to math 151, we are going to bring this all back up again. So it's good to kind of have some thoughts going already. So this special point that I marked on both of these, on the one that's face down, this is called the maximum point. And the one that's face up, this is called the minimum point. And they both have a common name that's called the vertex. So the vertex is either the maximum or the minimum point. And there's going to be two forms of the vertex, two ways that it can be written. So in your book on page 13, well, actually 615, we talk about if, so let's just say if in the form, so if you're given a quadratic in the form of this, y equals a x squared plus bx plus c. Okay, so if you're in that form, and we learned about this form in 7.3 when we were using the quadratic formula to find the y-intercepts, then let's just write all terms need to be on one side equal to 0. So for this to work, the second thing is your y-intercept will be, it's always when x equals 0. And so in that case, the ax squared will equal 0 when x equals 0, and the bx will equal 0 when x is 0. So you're left with c. So the y-intercept is equal to c or the point 0 c. The third thing is that your x-intercepts, okay, if they exist, remember sometimes you have, like up here, they do exist. So let me mark them. And the two that I drew here, they do exist because they do cross the x-axis. So if you have an equation like this, right, or like this, there's no x-intercepts. Okay. So if they exist, you can find them if it's in this form, ax squared plus bx plus c, by using the quadratic formula, but I'm just going to remind you, we're kind of putting it all together. So the net opposite of b plus or minus the square root of b squared minus 4ac all over 2a And then lastly, the vertex and how we find that. So there's going to be a vertex where x equals the opposite of b over 2a. Then y will equal the f of that x there. Okay, and we're going to do some so you can see what I'm talking about. So you're going to have a vertex. So the vertex will be an x and y coordinate. And the x coordinate is found by taking the opposite of b divided by 2a, just like how we used a and b up here in the quadratic formula. So the opposite of b over 2a will be the x value in the vertex. And then when you put that x value into the function, and the y comes out, that is the y value or the y coordinate of the vertex. Okay, so let's do a few of these, and then we're going to look at the other form. So if you go into the book and we look at problem number 1, so problems 1 through 12, it says, give the x-intercepts and the coordinates of the vertex and sketch the graph. Okay, so y equals x squared plus 2x minus 3. And so I'm just going to write out to the side a equals 1, b equals 2, and c equals a negative 3. And they ask for the x-intercepts. So we're going to use the quadratic formula. So x equals the opposite of b, so negative 2 plus or minus the square root of, and then 2 squared minus 4 times a times c, which is a negative 3. You have to be very detailed with this quadratic formula, all over 2a. So a negative 2 plus or minus 4 plus 12 over 2. So a negative 2 plus or minus the square root of 16. Oh yeah, that's one that comes out. So this is a negative 2 plus or minus 4 over 2. So we have 2 possible answers, a negative 2 plus 4 over 2, right? X could equal that. So that would be 1. Or the other one could be x equals a negative 2 minus 4 over 2. And that'll be a negative 6 over 2 is a negative 3. So that gives us 2 points to 5. Okay, and those 2 points here are 1, 0. That's the definition of an x-intercept when y is 0. And the other one is a negative 3, 0. So we can just, when I say sketch the graph, don't worry about going into Desmos. You can to check it, but I just want you to plot these 2 x-intercepts. So 1, 0, and a negative 3, 0. And then I'm going to give you a hint now. We might as well do it now, even though you're going to dive into this in Math 151. Your A, so when A, which is 1, is greater than 0, it's going to be a face up. So you already know that. Okay. And so we can draw this as face up. Now, I don't want to do anything down here until I know where the vertex is. So the vertex, the x on the vertex is going to be the opposite of b over 2a. So the opposite of b, so the opposite of 2 over 2 times a. So that's a negative 2 over 2 or a negative 1. So the vertex is a negative 1. And then we're going to put and then f of a negative 1. So a negative 1. And what does the function look like at a negative 1? Okay, so we're just going to put that in. F of a negative 1 is x squared, so a negative 1 squared plus 2 times a negative 1 minus 3. Now you could go and do this in Desmos as well. So that's 1 minus 2 minus 3 equals 1 minus 5 is a negative 4. So my vertex is at a -1 and -4. And so I'm going to plot that a -1, -4, that's going to be right about here. And so I'm going to just connect that, and that's what my graph would look like. So I'm going to show you all this in Desmos. What I'm going to do in Desmos is just put my original equation, and there's no reason why you can't check all this in Desmos to make sure you're doing this correctly. Okay, so I'm just going to make a note. This is number 1, and so it was y equals x squared plus 2x minus 3. Whoops. Plus 2x minus 3. There it is. Okay, so you can see if you hover over it, click on your graph. Oops, click on your graph. You hover over it, you should be able to click on your, whoops, your x-intercept should come up. My mouse has been weird today, so that's maybe why it's not showing the graph. So let me just do with my finger on my touch. But you can see they're right there, right there. And then you can also see the point here, the vertex. Your mouse should be able to hover over and do it. Like I said, my mouse is being weird today. Okay, so let's go and look at another one of these. How about we look at number 5? Okay. So let's go back and look at this. Okay. So number 5 is y equals x squared minus 1. So we said everything has to be to one side, set equal to 0. And so that's true. But we really want it to be in this form of y equals ax squared plus bx minus 1. So it looks like we're missing the x. So just so we can see everything, it's really x squared plus 0x minus 1 equals 0. So b is a 0 for this case. Now, I always want you to recognize I'm not going to force you to use the quadratic formula here, but I do want you to recognize a equals a 1, b equals 0, and c equals a -1. Okay, but to find the y-intercepts, we're going to put 0 in for x. So 0 squared is 0 minus 1 is a -1. So our x-intercept is at 0, -1. That's cool. Let's just kind of plot that. 0, -1. I don't think I found that on the last one, did we? We did not. So on the last problem, it should have been at 0, -3. So that should have been another point that we plotted. They didn't ask us for that on problems 1 through 12, but that's good to always see the y-intercept. That's a free point to look at. 2, we're going to look at the x-intercepts. Now, this is a special quadratic function because there's no x term, and so I can factor this quite easily. So I just want to show you that there's other strategies, remember, than the quadratic formula. So because there's no x term, I just have x squared minus 1, I can see that this is a difference of squares if I were to factor that. And then I'm going to use my 0 product property. So let's remind ourselves what we learned earlier in the semester, 0 product property, which says if either of these equals 0, so x equals 1, or x plus 1 equals 0, so that means x equals a -1, then those are x-intercepts. So we have one at 1, 0 and one at -1, 0. So we can go ahead and plot those, and they're symmetric. That's cool. So we can also see that A up here, A is equal to 1, and I just go right here and say greater than 0, so I know it's face up. So I can draw my graph right there. Now, the only reason I know that is because these are symmetric, so that has to be my vertex, but let's go and find our vertex using our formula. So that. So I'm going to find my vertex is an X and a Y. How I'm going to do that. So the X for my vertex is the opposite of B over 2A, and B is 0. So that's cool because that just becomes 0. Okay, so when we put 0 in, f of 0, we already know what f of 0 is because it happens to also be my y-intercept. So f of 0 is a -1. So we had our vertex given to us as well. Okay, let's look at number 7. So this one is y equals a -x squared plus 9. So x or a is equal to a -1. We can see that this is another one where we don't have a b, so b is 0 and c is equal to 9. And we said when a is a -1, when it's negative or less than 0, then we know it's going to be a face down. So that's kind of a good helpful thing. And then we know our y-intercept is always at 0, c. So that's 0, 9, 0 and 9. So I'm just going to pretend that that's 9 right there. Okay, and then we have to find our x-intercepts because it's face down. So we know we're going to cross the x-axis. Okay, so for our x-intercepts, we're going to set a -x squared plus 9 equal to 0. And I think I can factor this, but I'm going to just move everything to the other side. So everything's positive and 0s on the left. So when I do that, it's going to be x squared is positive over here and a -9, and then the 0s on the left. And now we can see that we can factor these. Now it looks like this equation is a face up, but that's just because I moved everything to the right. I only did that because I can see that I can factor this into a difference of squares, x -3 and x plus 3. So just like I did on our last problem, I can use my zero product property and set them each equal to 0. So x equals 3 and x equals a -3. So I have an x-intercept at 3, 0 and one at -3, 0. So here and here. And so I know that it's going to be this. And they're symmetric. So I also know that this is going to, because B is 0, that means our vertex is going to be at 0 again. So the vertex is x is equal to a -b over 2a. So that's going to be a -0 over 2 times a -1. So it's going to be 0 again. So it's already the point that we know of, which is our y-intercept 0 and 9. So that's the graph of our equation. Okay, so let's look at our second situation. Sometimes our quadratic equation is called the vertex form of the quadratic function. And I'm going to refer you to that. That's on page 619 in your book. 619 all the way down here at the bottom. So it says y equals a times this perfect square thing, x minus h squared plus k. A cannot be equal to 0. Then h and k are the coordinates of your vertex. And remember that h, just as it is, so it has to be a subtracting an h, and then it's the positive of that. So that part's kind of weird for some folks, kind of pulling that separate. So that's page 619. Okay. So it's y equals a times x minus h squared plus k, where a cannot be 0. So I'm gonna show you two so you can kind of see what I'm talking about. So we could y equals 3 times x plus 2 squared minus 6. Okay, so we have to think of this as like a subtracting a -2, because this has to be a subtraction for this h and k to work for the vertex. For the vertex to be at h and k. So for this one, the vertex would be at a -2, because we have to make that write that as a subtracting of h. And then k is whatever it is over here. So that is a -6. Okay. Or you could have y equals, let's say 3 times x minus 4, the quantity squared, plus 5. Okay, so that is h. It's written how it is. So my vertex in this case is 4 and then 5, just as it is, it's positive. So let's look at a couple from the book. So if we look at 13, 13 has y equals 2 times x minus 1, the quantity squared, plus 3. And it's asking us to graph each parabola, label the vertex and any intercepts that exist. So this is just a little bit different in how we find our y-intercept and x-intercept in the vertex. The vertex pops out this time, but other things are a little bit more complicated. So for the vertex, that's probably the quickest one to find first in this format, is 1 and 3. So let's just find that over 1 and up 3. And a is still a, so this is a. And so let's just write that up here again. So if a is greater than 0, then it's going to be face up. That is still the rule that I gave you last time with the standard form of the quadratic. And if a is less than 0, it's going to be face down, and that's still the rule. So because a, let's just write this up, a is equal to 2, which is greater than 0, so I know it's going to be face up. And this is the vertex, which means it's the minimum. So we are not going to have any x-intercepts. So no x-intercepts. There will be imaginary ones. They're called imaginary zeros. But visually on the graph, there's no x-intercepts. And let's just write that no x-intercepts because it is face up and the vertex is above the x-axis. Okay, the fourth thing is let's find the y-intercept, and just that gives us one other point to kind of draw this. The y-intercept is when x equals 0. So if we were to put x equal to 0, we're going to have 2 times 0 minus 1 squared plus 3. So this one's a little bit more intensive than it was before in the other format. So 2, and then that becomes a -1 squared plus 3. So 2 times a positive 1 plus 3. So that's 5. So this is at 0 and 5. Which makes sense. The vertex is over 1 and up 3. So that's at 3. And that's at 1. And then at 5 is where we're crossing the y-axis. And so it's going like that. It's going to look something like that. So isn't it fun that you're learning pieces without having to go to Desmos? We're learning all those pieces to give us clues on how to draw. So that was 13. So how about we look at 15? So 15 is the opposite, so negative. And just because it says negative in parentheses, it's really a -1 if you'd like to have something there visually for A. Okay, so we'll look at 17. Okay, so A is equal to a -1. So we know that's less than 0, so it's going to be face down. So that's good to know. And then let's just write down our vertex is, okay, that's a +2. So it's really like the opposite of a -2. So H is a -2, comma, K is a 4. So let's plot that point. So left 2 and up 4. So there it is. And because A is negative and it's face down, it's going to go something like this, right? So let's find our y-intercept. And by all means, you could just go to Desmos and find these to verify, but we're going to put a -1 in, a 0 in for x, oops, +2 squared plus 4. So a -1, 2 squared plus 4. So -1 times 4 plus 4. Remember, order of operations here are important. So kind of going back to those things we learned in chapter 1. So -4 plus 4 equals 0. So my y-intercept is at 0, 0. Okay, and so whenever we cross the x-axis, that's also an x-intercept. So to find the x-intercepts, we're going to set the equation equal to 0 and solve for x. So if we subtract 4 from both sides, we get a -4 equals a -1 times x plus 2 to something squared. So let's divide by the -1. So we get a +4 equals the something squared, right? And so we learned in the 7.1 lesson that if you have a something squared, you can just take the square root of both sides. And so when we do that, we get a plus and a -2 equals the x plus 2. Okay. So we're going to have the, let's do these here in 2 directions. So we've got the +2 equals x plus 2. So when we subtract 2 from both sides, we get x equals 0, which we knew was one of them from our y-intercept. So that's one of our x-intercepts. And then the other one is when you use the -2. So -2 equals x plus 2. And we subtract 2 from both sides and we get x equals a -4. So a -4 is our other 1, 2, 3, 4. And so it'll look something like this. -4. Okay. how about we look at a negative, or I'm sorry, number 17. So number 17 is g of x equals 1/2 times x minus 2 squared, subtracting 4. Okay. So a is equal to 1/2, which is bigger than 0, so it's going to be a face up. Okay. And let's go ahead and write down our vertex. Our vertex is at 2 and a negative 4. So 1, 2, 1, 2, 3, 4. So that's going to be the very minimum point. Let's just write that minimum point because it's face up, minimum point. Okay, so let's do the y-intercept next. So when we put 0 in for x, we're going to get 1/2 and then a negative 2 squared minus 4. So 1/2 times a negative 2 squared is a positive 4. And 1/2 of 4 is 2, subtracting 4 is a negative 2. So the y-intercept is at 0 and a negative 2. So 0 and a negative 2. There's the y-intercept. Okay. So we got to find our x-intercepts here. So that should have been the second thing we did. So the third thing we're going to do are the x-intercepts. Okay. So 0 is equal to 1/2 times x minus 2 squared minus 4. So we're going to add 4 to both sides. So when we do, this 4 is eliminated. Then we're going to divide by 1/2 or multiply by 2, right, to cancel that. So we get 8 times the something squared. And so when we take the square root of both sides, we get the something, the square root plus and minus, the square root of 8 equals x minus 2. And because we want to actually plot these points, we can go ahead and find the decimal of that. That's fine. Square root of 8 is approximately 2.83, we'll say. So we're going to say the positive of 2.83 equals x minus 2. So when we add 2, we get 4.83 is one of them. So 4.83 comma 0 is one of my x-intercept points. So that's 2, 3, 4, almost to 5. That's one of them over here. It's going to go something like that. And then the other one is going to be the negative 2.83 equals x minus 2. So when we add 2 to both sides, we get x is equal to a negative 0.83. So the other x-intercept is at a negative 0.83 and 0. Oops. And that is right about here. So that's what it's going to look like. Okay. How about we do one more? Let's do 19 together, and then we're going to do a couple stuff. So number 19, we have f of x equals negative 2 times x minus 4 squared, subtracting 1. So the first thing I'm going to recognize is that a is a negative 2, and it's less than 0, so it's going to be face down. And then I'm going to find my vertex. So that's going to be at 4 and a negative 1. So 1, 2, 3, 4, and down 1. So it's going to be right about here. And it's face down. So that's going to be interesting. So we already know, right? No x-intercepts. Because our vertex is already below the x-axis. Okay. So we can find the y-intercept though, just so we can see where, at what point do we cross that. So when we put 0 in for x, we simplify here, make it a negative 32 minus 1, so a negative 33. So 0 and a negative 33. So this is going to be way down here, right? To be able to draw that. So let's look at some of the story problems. These are good ones. So 39, let's just get out the book here. So 39 says they want to find a maximum profit. A company finds that it can make a profit of P dollars each month by selling X patterns. According to the formula here, how many patterns must it sell each month to have a maximum profit? What is the maximum profit? So they gave me the function on these. I am all about putting them into Desmos and seeing a maximum. We can see that A is a negative 0.002. So we know it's going to be face down. So that's going to be our vertex. So it says, how many patterns must it sell each month to have a maximum profit? That would be X. And what is the maximum profit? That would be your P of X, or your output. So X number of patterns and then P of X is the amount of profit. Let's go to this is 39. Okay, so let's just type in y equals, and instead of P of X, we're going to do y, and it's negative 0.002 x squared. And then it's plus 3.5 x, and it's 800. Okay, so I'm going to turn off my other graph, and then I'm going to, because this, so we can do some zooming out. Oh man, I'll do the gear, so it, and I'm going to turn the table, and then I can click on the magnifying glass, so it'll give me a proper graph. Okay. And we can't really see it because trying to zoom out so we can see a realistic maximum here. It's because we've got that plus 800 that's making it so. So I'm gonna hit my magnifying glass again. No. Okay. We should be able to. Oh gosh. I apologize. My mouse is just being so weird today. It's not giving me my maximum here. So I guess we get to find our vertex here, which would be our maximum. So the opposite of B. So on this, B is a -3, is 3.5. So it's going to be -3.5 divided by 2 times A, which is a -0.002. And so when X is equal to 875, so then I can go up to my table and then put in 875 and it will give me the output. And there it just plotted it on the graph. So that is my max, my vertex. So I'm just going to make a note here so you can see it here in Desmos. The vertex is at 875 comma, oh sorry, 875 comma 731.25. Okay, so let's just write that on our paper. We have to make our 875 patterns to profit 731 and $731.25. I think it's picture. Oh wait, 39. Sorry. Yep, 875 patterns to make $731.25. So let me just share my screen again. So 875 patterns to make that much profit. It's not a lot of profit. That's a lot of patterns. Okay. There is another one that is let's pick another one here to do. That would be good. Let's do 43. It kind of challenges us a little bit. So 43 says, a company that manufactures smartphone cases knows that the number of cases X it can sell each week is related to the price P of each case by this equation. This is how many it will sell X when it offers it at a price P, when they sell it at the price P. Graph the revenue equation, R equals X times P, then use the graph to find the price P that will bring in a maximum revenue. Finally, find the maximum revenue. Okay. So the key is that revenue is equal to X times P. And so we already know X is equal to 1200 minus 100P times P then. That's that P. And so we can put it in like this into Desmos, but we could multiply through and say this is 12P minus 100P squared. And so if we flip this around so that it was a negative 100P squared plus 1200P plus 0, you could kind of get a visual of this is our A, that's our B, and that's our C. And so because A is equal to a negative 100, which is less than 0, it's going to be face down. So that's why we're going to have a maximum value of where this revenue is. It's going to go up and hit a maximum. And then at some point, the higher the price that you charge, then your revenue is going to go back down again, right? Okay, so let's just go to Desmos and play around with this. See if we can get this to work. So this is number 43. So we have y equals, and we're going to put in x for p just because that's the equation. 1200 minus 100x times x. We're replacing p with x because Desmos only allows us to use that. So let's go up here and turn off this other graph that we had. And I'm going to go to our new equation and turn on the table. That one. And then we're gonna, hopefully I can get my mouse to do it. Okay. Okay, so our next one is going to be up here somewhere. So let's just do our vertex like we did before. So the opposite of B. So in this one, we said our B was 1200. So it's going to be the opposite of 1200. So another 1200 divided by 2 times A, and A is a negative 100. And so there is the X value of our vertex is 6. And then when we go up in our table and we put 6 in, we get 3600. So our vertex is at 6 and 3600, and you can see that here on the graph at 6 and 3600, then it goes back down again. So I'm going to take you back to my paper so that we can interpret it together, and I will make sure that this link is up in a Canvas Plus as well. Okay, so this is 6 and 3600. So we said when they sell the earphones for $6, the maximum profit revenue, right? Revenue. Oh, these are cases that we're talking about. Maximum net. So cases. When they sell the cases for the smartphone, when we sell them for $6, they're going to have a maximum revenue of $3,600. And if they sell those cases for any more, then the revenue starts to go back down again. So that concludes 7.5, and let me know if you have any questions over the assignment.